All right, so remember we discussed the other day what a piecewise function is. You can look in section 1.4, I believe is where we did it, where we talked about what a piecewise function is. So today we are going to see if we can graph our piecewise function. All right, so that's what our directions say. Graph the piecewise function. I think we're on, what, example 3? All right, so I'm going to use a highlighter just to help point some things out to you. So if you want to grab one, you can. Okay, so for a piecewise function, remember that you have more than one piece and it's on a restricted domain. So we're going to have this graph up to -2, and we're going to have this graph past a -2. So the way that we're going to handle this is, there's really two ways. I'm showing you the easiest way for everybody to understand. If you've learned to do this before and you can do it without making a t-table, I'm okay with that. But it's easier for a lot of people if they make a t-table, so that's what I'm doing. Sorry, I'm trying to think and talk and it's not working out. Okay, so I have myself set up. Now, what I need to remember is that I'm plugging into one function for part of the time and the other function for the other, and that split happens at this -2. All right, so -2 has to go on my t-table twice because I have to know what happens with both pieces so that I know where that overlap point is, but then I open or close a circle so that it's still a function and it doesn't really overlap. All right, so just a few numbers on either side of -2. So we're going to go -5, -4, -3, -2, and then -2 and some numbers on the other side. -2 again, -1, 0, 1. All right, so that gives me 3 values on either side. That should be enough. All right, so here's what we're going to do. We have, well, I grabbed a green highlighter, but it's like kind of a green color, so let's not do that. So for this top piece, this is talking about when x is -2 or smaller. So that's going to be this part of my graph. All right. So right here at -2 is where we kind of split from one piece to the other. For this -2, we're going to plot that point with a closed circle because it has the equal to. This -2, we're going to plot with an open circle because it doesn't have an equal to. All right, this is the top of the function. This is the bottom of the function, looking up here, top, bottom. All right, so for the bottom of the function, that's all the values bigger than -2. So that's all of these guys. And again, I'm plugging -2 in there because I need to know what's happening at that spot. I'm just going to put a open circle there. All right, so if I plug in a -5 to the top function, because -5 is smaller than -2, then I have -1/2 times -5, so 5 halves, which is 2.5, plus 2 gives me 4.5. So I have a point at -5, 4.5. All right, -4. You have -1/2 times -4, which is +2, plus 2 is 4. So there's a point at -4, 4. All right, plugging in a -3. -1/2 times -3 is 3 halves, or 1.5, plus 2 is 3.5. plugging in a negative 2, you have negative 1/2 times negative 2 is 1, plus 2 is 3. All right, and then we know it's linear, it makes a line, it looks like that. So this is the top portion graphed. All right, for the bottom, we plug in negative 2. You get negative 2 minus 3 is negative 5. We're going to plot that point. But we're going to plot it with an open circle because there's not really a point there, but we need somewhere to start from because anything all the way up to that point is going to be part of our function. All right, so if I plug in a negative 1, you have negative 1 minus 3 is negative 4. Plug in a 0, 0 minus 3 is negative 3. Plug in a 1 minus 3 is negative 2. And then, so it's like a split right here. So we graphed these points, put an arrow that way because they go that direction. You can see from here. And then here we're going to start with that open circle and we're going to go this way. And you can see that because it's like it points that way. That little symbol does. All right, and so this goes with everything else that's highlighted orange. All right, so that's parent function number 1, graphed. All right, let's see if we can graph a second one. If you want to pause the video and see if you can do this next one by yourself, I'll tell you that it's a little more complicated, but I bet you can handle it. All right, so we have g of x. We have 2x plus 1 when we are less than or equal to negative 1. We have 2x squared minus 1 when we are from negative 1 to 1. And we have 1 minus x squared when we are from 1 on, so anything bigger than 1. All right, so again, we need to make a t-table. We need some values that are smaller than negative 1. I'm going to run out of space. I should have started another page, but I didn't, so we just got to make it work. Then we need negative 1 to 0 to 1, so we'll do 0, 1, and then we need 1 and a couple of numbers bigger. All right, so again, these numbers are in there twice because on one it's going to be an open circle and on the other it's going to be closed. So here we have an equal to, so closed, but in the middle one, we do not have an equal to here, so we're open. But we do have an equal to on the 1, so closed. And then we don't on the bottom section, the bottom function. That one's going to also be open because there's no equal to. All right, so let's see if I draw my graph. Okay, so here we go. Oops, sorry. Grab my highlighters. Okay, so all of these numbers we picked because they were smaller than negative 1, so they go into the top because it says less than or equal to negative 1. All right, so if I plug negative 4 in, I'm going to get negative 8 plus 1 is negative 7. Plug in negative 3, that's negative 6 plus 1 is negative 5. Plug in negative 2, that's negative 4 plus 1 is negative 3. Plug in negative 1, it's negative 2 plus 1, which is negative 1. All right, this is a line. So when we plot our points, we should have a portion of a line. So negative 4, negative 7, negative 3, negative 5, negative 2, negative 3, negative 1, negative 1. And it's to the left because it's smaller, so we're going to go that way. All right, so that's all the top. All right, so talking about the middle section, if I plug in a -1, and again, I know these numbers go here because they fit this description. All right, so -1 squared is 1, times 2 is 2, minus 1 is 1. 0 squared is 0, times 2 is 0, minus 1 is -1. 1 squared is 1, times 2 is 2, minus 1 is 1. This is a quadratic, so it should make a U shape or part of a U shape. Okay, so if we go -1, 1 with an open circle, 0, 0, nope, not 0, 0, sorry, 0, -1 is a point, and 1, 1 is a point closed circle. So that makes a perfect little U. We just kind of cut it off. Okay, so sorry y'all, there's a little hiccup there. Somebody walked in, I had to pause the video and restart it. So that's our middle chunk, our middle piece. It's these values right here in this little part of our graph. All right, so for the bottom, if we put in a 1, 1 squared is 1, so 1 minus 1 is 0. 2 squared is 4, so 1 minus 4 is 3. 3 squared is 9, so 1 minus 9 is 8, -8. Sorry, I didn't say -3 while ago either, I don't think. All right, so 1, 0. We have a point here, but it's an open circle. And then at 2, -3, we have a point. And at 3, -8, we have a point. Now, I know it looks like these kind of like go with each other. That's just because I'm not on graph paper and I can't draw. All right, also, it kind of looks like these might make a line, but we know it's quadratic. We know that there should be like a curve to it. It should go, it should go kind of like this from there. All right, so that bottom piece is this part right here. All right, I'm going to tell you that this is the thing that people struggle with the most out of chapter 1, so it's going to be okay. Do your best on your assignment. We will discuss it when you come back to class. All right, the other thing that I did not do that's in here, it was actually in your class starter last week where we had to write a linear function. All right, so number 5 has its own set of directions. We want to write the linear function f such that that function has the indicated function values. All right, so number 5 says that f of 2/3 is -15/2, and f of -4 is -11. All right, so again, we did this in your class starter. Remember that this is really just saying there's an ordered pair at 2/3, -15/2, and there's an ordered pair at -4, -11. All right, so also remember that we know that we can write the equation of a line given 2 points using point-slope form. Okay, so the first thing I have to do is figure out the slope. So the slope between my points, we're going to subtract the y's over subtract the x's. All right, so, and you can do, like the order of these doesn't matter. You could have written negative 11 minus negative 15 halves. Like, either way is fine. If I do negative 15 halves minus negative 11, that's negative 15 halves plus 11, which is going to work out to be negative 7 halves. Because you can call this 22 over 2. And so negative 15 plus 22 is negative 7. For the denominator, this is going to be 2/3 plus 4, or 2/3 plus 12/3, so 14/3. All right, so now we're going to multiply by the reciprocal, so we have negative 7 halves times 3/14, which is going to, we can cancel here, so negative 3/4 ultimately. All right, so once you have your slope, pick one of your points. Now, why on earth would you pick fractions if you don't need to, right? So I'm going to pick this as my point that I choose so that I can plug in an x1 and a y1 to my formula. So x1 is negative 4 and y1 is negative 11. All right, so I have my m, my x1 and my y1, so I can plug in. So we have y minus negative 11 equals negative 3/4, and then x minus negative 4. So this is y plus 11 equals negative 3/4, x plus 4. And again, if it's an open-ended question, you could really stop here, but they like for it to be solved for y, especially on a multiple choice question. So we're going to distribute the negative 3/4. Good thing here is those 4's cancel, so this is just 3. And then we're going to subtract 11. And that is your answer. All right, so if you got hung up on the fractions over here, just go back and rewatch it. And I think you're going to be okay. If you're still confused, then email me with a question. I can send you a short little video of all of that work. All right, I think that is it. Make sure that you glue those parent functions in.